Hi guys, welcome to today's lesson. So today we're going to be looking at some algebraic expressions. We're going to try and look at what are expressions, and then we're going to look at what is equations, how do you solve them, how do you factorize, and how do you then simplify, because at times they just say to you simplify. Remember, there's differences between simplifying and factorizing. Don't think that it is the same thing. But for now, let's just look at our concept map of what exactly is it that you're going to be doing in this lesson. So, firstly, I want you to just think about this. Have you ever thought of why someone came up with all these ideas that we are using in algebra, right? Exactly what is algebra? I know that at times it becomes one concept that kind of has a lot of rules for us to understand. So what we then have here is we're going to talk about expanding terms. With the expanding terms, it will be a monomial with a binomial. Remember, monomial is 1, binomial is 2 terms, and then a binomial and a binomial, and then lastly a binomial and a trinomial. And trinomial, you know, it's 3 terms. We're also going to look at some algebraic fractions. That has to do with finding the LCM or the LCD and trying to then simplify those. Also, we then lastly going to look at some factorizing. Factorizing, we have some different types of them. It's finding a common factor. They normally call it a difference of squares, which is dots. They normally use the word DOTS, which is dots. And we're also going to factorize a trinomial. Then lastly, we're going to factorize cubes. The keywords for us to look at is the law that you've been doing ever since you tried to do some proper algebra, which is called the distributive law. Also, some binomial, as I said, is when we have 2 terms. Also, a trinomial will be when we have some 3 terms that we are dealing with, right, as an expression. Now, the distributive law is used to expand algebraic expressions, right? And then I'm trying to show you how to actually do that. When you distribute, the first one will be when you multiply the A with the B, the A with the C, which will then give me AB plus AC. Remember, guys, as it is saying, distributive law, you are taking what is outside the bracket and distribute it using multiplication to everything that is inside the bracket. That's what distributive law is all about. That's how we remove the brackets after all, just to follow that BODMAS that we've been learning when it comes to algebra. Also, the variable A is distributed, as I just said, and this is done multiplication. Now, with a binomial, excuse me, will be an algebraic expression of the sum or difference of 2 terms, right? So this will be either A plus B or A minus B. That's what a binomial is about. It's when we have 2 terms. Now, to multiply 2 binomials, we use what we call FOIL. And the FOIL is like an abbreviation of certain rules that we use. The F stands for first, the O stands for the outers, and then the I stands for the inners, the L stands for the last. But let's actually see what exactly this means. Using the FOIL method, when I'm talking about first, it will be the first terms in the 2 brackets that you have, and then my O will be the outer terms, right, which is the A and the D, meaning the ones that on the outsides of those brackets. And then last, it will be the inners, which will be the inner ones in the 2 brackets. Then lastly, it will be the last, which will be the last term in each bracket. And you multiply them. That's what FOIL is about. Now, when you're squaring a binomial, remember that when we did exponents long time ago, we looked at what exactly does this 2 mean? The 2 means that whatever that is inside the bracket is multiplied by itself, right? If it's 3, it means it is multiplied by itself 3 times. If it's 4, it's multiplied by itself 4 times. So when I square a binomial, it means I am repeating exactly what is inside the bracket without changing it and multiplying it by itself, as you can see here on the right hand side. And then you use the FOIL method to then multiply these two binomials, which will give me the a multiplied by the a will give me a squared. The a multiplied by that b there will be ab, and then the b multiplied by the a will also be ab. So now I have two like terms, which is ab plus ab, which gives me the 2ab in the middle here. Then lastly, it will be the b multiplied by the b, which gives me the b squared there. So that's what squaring a binomial is all about. Just also one note to make here. Please don't make the mistake of thinking this squared means that you must distribute that 2 to the two exponents and make it a squared plus b squared. Please, exponents are not about that, especially if you are squaring more than one term. If it was multiplied between, then we would use that. Now let's look at a trinomial. A trinomial will be an expression consisting of three terms. An example will be a plus b plus c. To multiply now a binomial by a trinomial, you use the distributive law. What that means is you take the first term of the binomial, multiply it by everything that is inside the bracket of the trinomial, and then you take the last term and multiply it by everything as well that is in the bracket of the trinomial. And from there you will have my ax plus bx plus cx plus ay, by, and cy with a plus in between them. Now let's just look at some questions just to try and put this into now perspective. Exactly what are we talking about? The first question I have is 3x into x plus 3. So to simplify this, we're going to use the distributive law, right? And the question will specifically say to you, expand and then simplify the following. The expand word means distribute or FOIL it out. After doing that, then work out the like terms. Don't just distribute and leave it like that. If there are like terms, then work them out. Also, on the note of like terms, remember for two things to be like terms and they are variables, they must have the same exponent and the same variable. So x and x squared are not like terms, although they are two variables that are the same. But x squared and x squared are then like terms because of the exponent that is the same and the variable that is the same. So please make sure that you do understand the concept of simplifying like terms. Now with this one here, if I multiply the 3x with the x, I will then get this as 3x squared, and then the 3x with the 3 there, it will be plus 9x. And from there, there is really nothing that I can do here. This is not equals to 12x cubed, because that's one of the mistakes that you guys make. It is not that. I just said for them to be like terms, they must have the same exponent. So this is an exponent of 1, this is an exponent of 2. So you just leave it as is. The second example, we are squaring x plus 1, right? So this becomes x plus 1 into x plus 1. And then from there, you then use your FOIL method. The x and the x will give me x squared. The x and the 1 will give me plus x. The 1 and the x will give me also plus x. Then lastly, the 1 and the 1 will give me plus 1. And therefore, if you simplify this, it becomes x squared plus 2x plus 1. And this becomes my final answer. Please don't then include another equal to and make it equal to 0 and then thinking you are then solving for x. No, the goal is just to expand and leave it in its simplest form. And also, the simplest form has to do with you leaving the exponents in a descending order. That's what a quadratic equation is all about. The other example we have here is also still a binomial multiplied by a binomial, and I'm just gonna go straight to using FOIL here. The 3y and the 3y will give, and the 2y I mean, will give me 6y squared, and then the 3y with the 4 will give me plus 12y, minus 1, and that 2 there will give me minus 2y, and then lastly the minus 1 with the 4, it will give me negative 4. And this will end up being 6y squared, because the two middle terms are like terms. It will then be plus 10y minus 4. And that becomes my final answer. And then you just leave it there. Remember, these are not like terms. You can't do anything further than this. Another example that we have here is, now we're going to apply some laws of exponents here, right? Remember, algebra, guys, is a combination of everything that we've done in maths. So here, if I multiply the 2x cubed with the x cubed, it will then give me 2x to the exponent of 6. Please, don't make the mistake of thinking you multiply the 2 with the 1 and then the 3 and the 3. No. Remember, the rule is if you are multiplying powers of the same base, you must then add the exponents, right? So I must add the 3 and the 3 to get the 6. Then 2x cubed multiplied by minus 2y will give me negative 4x cubed y. Someone can ask, why am I starting with the x and not the y? Because remember, mathematically, we always follow the alphabetical order when it comes to the variables. Then plus the 7 multiplied by the 1, there will be 7x cubed y. And then lastly, it will be plus 7y multiplied by the 2, there will give me negative 14y squared. Then this will then give me 2x to the exponent of 6. I can't do anything to that, but you can clearly see that the minus 4x cubed y and the 7x cubed y are like terms. So you then need to simplify them, right? When the signs are not the same, you subtract and then take the sign of the bigger number. So this becomes plus 3x cubed y. Then lastly, it does not have a like term, it just remains 14y squared. And that becomes my final answer for this. And again, let me just show you, if we're to mark this, the main thing will be you knowing how to expand properly, and then you having all the proper signs there, right? So it will be more or less 4 marks or maybe 3 marks that I'm gonna give you for each and every term on the final answer there. So that's just one of the ways that this can be marked. I'm not saying it is the actual way, but it's just one of the ways, depending on what I'm trying to test from you. The other one is, I'm having here a binomial multiplied by a trinomial, right? Remember, binomial by trinomial, you use the distributive law. So this is actually the same as, let me just try and simplify it for people like myself who are still trying to understand this. It is the same as x into x squared minus xy plus y squared, and then plus y into x squared minus xy plus y squared, right? So this is what the distributive law is all about. And then you start multiplying what is outside with what is inside the bracket. So this becomes x cubed minus x squared y plus y squared x, right? But we just need to start with the x, because remember I just said we normally write them in alphabetical order. So this will be x, y squared. Then let's go to the other bracket. When we remove the bracket, it becomes plus x squared y. Then if I multiply that one, it becomes minus x y squared. If I multiply the last one, it will be plus y cubed. then if you simplify this further, it will then be, you group them according to like terms, right? And you can see that this one here is a like term with the x squared y there. And then the x y squared will be a like term with that one, right? Then one of the other things I want you to please pay close attention to when doing your algebra is the issue of signs, right? Because that's one thing that makes you guys not to get this correct. Make sure that you understand your signs. The sign that is in front of the term goes with the term. The one behind it has nothing to do with that term. So if it's minus 2x, it means the minus goes with that 2x. But if it's minus 2x minus y, the minus after the 2x has nothing to do with that 2x, but everything to do with the y that it comes before. So please make sure you understand the concept of your signs properly, please, because it is really, really what makes algebra to be what it is. Now, with this one, I have minus x squared y plus x squared y, which then gives me 0, because it is the same as me saying minus 1 plus 1, right? Because there's 1x squared y and 1x squared y there. You are subtracting them. So I'm only left with my x cubed there. Let me just go back to my color so that I can show you. All right, so I'm going to be left with just x cubed there. The minus x squared y and x squared y is 0. The xy squared and the xy squared will also be 0. So this will be plus y cubed. And this we then call the concept of a cube, right? So the main thing here, guys, that we've been looking at so far is looking at what we call distributive law, which is very important when we're talking about simplifying. The distributive law has to do with a monomial multiplied by a binomial. Number 2, a binomial multiplied by a binomial, and then we employ what we call FOIL. And then lastly, it will be a binomial multiplied by a trinomial, which we also employ the distributive law. And from there, you will then be able to then look at what is it that they want you to do. Also, listen to the instructions carefully, please. When they say to you, expand and simplify, that's all you need to do. You don't need to then end up saying x is equals to and x is equals to. No, I just want you to then expand it by applying the rules that can be applied there and leave it in the simplest form, meaning you work out your like terms and then leave it there. For now, guys, I hope you are understanding so far what we are doing and you are having so much fun like I am. Let's just take a quick break and I'll be back with some more. Hi guys, I hope you are back and you had some water and you've refreshed a bit. So we're still looking at the concept of algebraic expressions, right? So far we've looked at the concept of expanding using the distributive law, using FOIL, which has to do with when it's a binomial and a binomial, and then lastly, which was a binomial and a trinomial, and we're using the distributive law. Now we're going to look at the concept of factorization, right? Or factorizing, if you like. So this has to do with, before we gave you in brackets, we then wanted you to write it as a quadratic equation or as an expanded notation. Now I'm going to give it to you as an expanded notation. Now I want you to go back to the brackets. You understand? So it was a plus b in brackets, a plus b in brackets. Then you get your answer. Now I am giving you the answer that you got. I want you to take it back to being a plus b and a plus b. But let's just look at the types of factorizing that we do have in maths. So some keywords that you need to look at is what we call a common factor. I know that by now you know what a factor is. And then common will mean that it is the same throughout the number of terms that you have. We also have what we call the difference of two squares. Remember I said we shorten it and say it's just dots. Now when factorizing, we have some different types of factorizing. One will be when we are taking out a common factor. The other one will be when we are trying to look at a difference of two squares. I will explain further what this is when we get to that point. And then also a trinomial. Remember a trinomial, we've already spoken about this. And then a cube will just be something to the exponent of 3. Now, taking out a common factor, this means that you are dividing each term by the highest common factor. Example, if I have 2a plus 4, my highest common factor here will be 2 because 2 is divisible in 2a and it is also divisible in 4. If I divide 2a by 2, I will be left with only a. I divide the 4 by 2, I will be left with 2. Such that if I was to remove the bracket, it will take me back to what the question was. So that's what taking out a common factor is all about. Let's look at another example. If I have m squared minus 3m, my highest common factor here will be m. Divide m squared by m, you get just the m there. Divide minus 3m by m as well, you get minus 3. Such that if I distribute the m, it will take me back to what the question was. Guys, remember in maths we are dealing with balance. If you simplify something and you can't take it back to what it was originally, then you are lying there. You are not doing the right things. I will not say you are wrong. I always say people are lying because you know the correct answer, but you just choose not to write the correct one. Now with the difference of two squares, this is when a perfect square minuses a perfect square. But let me explain, guys. I know that when we started looking at a perfect square, we said a perfect square is a number that you can find inside a square root. But now in algebra, that's not what we're talking about. A perfect square will be a variable that is raised to an exponent that is an even number. So 6 as an exponent is a perfect square. Why? Because remember, a perfect square, the actual definition is, it is a number such that I can multiply two numbers that are the same to get it. So 4 is a perfect square because I can multiply 2 and 2. 16 is a perfect square because I can multiply 4 and 4. Same thing with a to the exponent of 6. I can multiply a to the exponent of 3 with a to the exponent of 3. So it is also a perfect square. So I hope that kind of makes sense to you. But with this one, the example I have here, it's a squared minus a squared. If you factorize this, you normally open two binomials which will have exactly the same factors but with different signs, right? Because remember it says difference of two squares. So it will be a plus b and then a minus b. Some people ask me if it is a minus b into a plus b, is it still the same? Remember guys, 3 times 2 and 2 times 3 is one and the same thing. So it doesn't really matter as long as it's multiplication between them. Now we have the most beautiful one and the one that you guys normally try and then flunk on, a trinomial. With a trinomial, guys, to factorize this, one, you must make sure that it is in the correct order. What do I mean? Ax squared plus bx plus c. That's the correct order. Your exponents must be in descending order. So it's 2, 1, and then here it's normally x to the 0, but you know x to the 0 is 1. That's why it's not there. So your exponents must always be in descending order of the main variable that we're dealing with. Number 2, make sure that you test for a common factor. Can I take out a common factor in all these 3 terms that I have? If yes, do it. If not, then it means you're gonna go straight to the following thing that I'm gonna tell you now. If you can't take out a common factor, you look at the last sign. What do I mean by last sign? So ax squared plus bx plus c. The plus c, this plus there, that's the sign I'm talking about. You look at the plus, meaning the sign of the last term. If the sign of the last term is a positive, it means my two brackets will be positive or negative and negative. So it's either both positive or both negative, because that's how you get a positive, right? But if the last term is then a negative, it is definitely going to be opposite signs, a plus and a minus, or a minus and a plus, depending on which one you want to start with. But my advice to you will be always start with a positive. It makes life a bit easier for you. We also have what we call grouping. Grouping is to create the same common factor. You always make sure that each bracket is in its simplest form, right? What do I mean? Let's look at the example. 3x squared plus 2x, 12x plus 8. I've already grouped them. Why did I group them like this? It's because I want to create a common factor between them, right? So if I take out a common factor for the first binomial, which will be x, I will be left with 3x plus 2. I take out a common factor for the second binomial, which is 4, I will be left with 3x plus 2. Voila, the common factor is there, which is the 3x plus 2. Then the last step will be, if I take out the common factor of 3x plus 2, I will be left with x plus 4 in one bracket and then 3x plus 2 in another bracket. So that's what grouping is about. You are creating the same common factor and making sure that each bracket is in its simplest form. Now we're talking about cubes, right? Cubes will be something raised to an exponent of 3. We have two things when it comes to cubes: the sum of cubes and the difference of cubes. With the sum of cubes, to simplify it, the formula will be the one I have for you on the board. A cubed plus b cubed will be the same as a plus b as a binomial, and then as a trinomial, a squared minus ab plus b squared. And then I have some rules for you to actually look at. That if it's a plus here, which is a sum, then the trinomial, the middle term, will have a different sign, but the binomial will have the same sign as what your cube was, right? And then the last term of the trinomial will forever and ever be a plus. Always a plus. Let's look at a difference of cubes. With a difference of cubes, still the same concept that we are looking at. If it's a minus here, my binomial will also have a minus. And then if it's a minus here, the second term of the trinomial will have a different sign, which is a plus, but the last term is forever a positive. Now let's look at some factorizing fully. What did I say? Firstly, look at whether I can take out a common factor or not. If I can, that's what you need to do. So here clearly I can take out a common factor of 5. And if I do that, I will be left with x plus 1 all squared minus, if I divide this by the common factor, it will give me 25, right? And then from there, inside the bracket, I can then factorize that, because then this becomes the difference of two squares, dots. So it becomes 5 into x plus 1, that's the factor for this one, minus 5. And then in another bracket, it's also x plus 1 plus now the 5. And then you can simplify it further, right? So this becomes 5 into x minus 4 into x plus 6, and then you can close your bracket, and that's the simplified version of it, which is the factorized fully part. Now here is a difference of two squares. Remember, this is a perfect square. 49 is also a perfect square. X to the 4 is a perfect square. Y to the 2 is a perfect square. So this will become 8x squared minus, so I said you must start with a plus, right? So let me do what I said you should do. 7y there. In the other bracket, it becomes 8x squared as well, minus 7y. Remember, guys, the brackets must have the same things, but with different signs. That's how you factorize difference of two squares. There is nothing else I can do here, guys. On this bracket, I can't factorize it because 7 is not a perfect square. But if it was, then I would have to continue and factorize some more. Now, factorize fully here. Remember, I said if it's a trinomial, you look at the last sign. If it's a minus, it means your two signs will be different. So this will be x into x, and then the factors of 4 such that they give me 3. It will be 1 and 4. And then I will have the 1 as a positive and the 4 as a minus because of the middle term there. The last one here will be, so remember with this one, you multiply these two, right? They give you 4. The factors of 4 will be 4 and 1 to give you the 5, right? So meaning here it is the same as 4x plus x, right? So that's how you can kind of find what the factors are. But that will just be 2x plus 1, and this will be x plus 2, and it will give you the same answer. Now, factorize fully, this is in the form of grouping. If I group this, already they are kind of grouped for you. You just need to make sure that each of the two binomials you can take out a common factor, and then they will give you the same common factor so that you can take out another common factor. So this is a into x plus 3, and then plus the common factor is 2 here, which is x plus 3, and then you can see x plus 3, x plus 3. So this becomes x plus 3 into a plus 2, and that will then be my final answer there. One last example, this is a difference of cubes, right? So you treat this, remember, as a cubed, and then this will be the b cubed. So this is the same as 2 to the exponent of 3 minus 3b, all of this cubed. And then you can then factorize this. If it's a minus there, the binomial will have the same sign. So it will become 2 minus 3b. The trinomial will then be 2 squared, but the middle term will have a plus, which is 2 times that, that's 6b. And then the last one is always a plus, which is 3b. All of this must be squared. And then you can simplify it further to get the answer from there. And then you will be okay. Now, guys, so far what we've looked at is the concept of factorization. Please make sure that you understand these different types of factorization, especially the trinomial, because I know that's where you guys kind of make some mistakes, right? When you're taking out a common factor, it's the highest common factor. You divide each term by it and then put it outside the bracket. Don't include now and introduce an equal sign that was miraculously not there and then now it's equal to 0. No, it must just become an expression. From me to you, for now, guys, take a walk, relax, rest your brain a bit, and I'll be back with some more. But I hope you are having fun, because trust me, I'm having so much fun. I'll be back just now. Hi guys, welcome to the last segment of our show. So right now, guys, we've been looking at a whole lot of things. I hope you guys have grasped everything that we've looked at. Wherever you're not understanding, just go back to the notes that you've been making, go back to your textbooks, look at all the other options that you have, and try by all means to make sure that you understand this, because I promise you it is going to form the basis of you understanding your whole algebra. until you finish with your mathematics career whenever you do decide to finish, right? So now we're going to look at some fractions. The fractions, it will be adding fractions and dividing and multiplying fractions. Remember, the opposite of adding is subtracting, right? But let's look at some key words that we need to look at before doing some fractions. So firstly, we have what you call the lowest common denominator. I know you guys, you started doing this when you started, as an LCM, right? Which was lowest common multiple. Now we're gonna call it the lowest common denominator, which makes it a bit easier to use in terms of fractions. Now when adding and subtracting fractions, first you need to determine the LCD. Now, for example, if I have 1 over 4x squared and 1 over 3x squared and 1 over 2xy, you must find the LCD must be a number such that all the denominators are divisible in that without leaving a remainder. So a number that 4 and 3 and 2 can go into and not leave a remainder will then be 12, right? That we do know. Because 4 multiplied by 3 is 12, so 4 is divisible in there, 3 is divisible in there, and 2 is divisible in there. Then from there, x squared and x cubed. I know that x cubed has x squared in it and also has that x there, so it becomes x cubed, and then I also need a y because the last one has a y, right? Now, remember when you're dealing with fractions, the goal is to always have your denominators to be the same. So you will multiply each fraction by whatever factor that will make the denominator to be the same, which is in this instance 12x cubed y. Now also, another example is I have x plus 2x squared plus 2x. Firstly, I must simplify this. It becomes still 1 over x plus 2. I'm going to leave that. But this one I must simplify to x into x plus 2, right? So you can already see that the x plus 2 is already common. So I already have x plus 2 as my lowest common denominator. And then I also need x there. So it becomes x out there. Then you will multiply each term by whatever factor that you must multiply it by in order to get that denominator that I have there. Remember, when dividing a fraction by another fraction, you always need to do what we call the tip and times, right? To simplify. Tip and times means if it's a over b divided by c over d. This is going to be the same as a over b multiplied by d over c. So what's on the right-hand side of the division sign will then be tip and times. Whatever was a numerator becomes the denominator. The denominator becomes the numerator. And then you need to factorize the numerator and factorize the denominator wherever it is necessary. Like in the previous example you saw, I had to factorize my denominator there before even simplifying this thing. Now let's look at some questions just to remember we always need to bring this into perspective. Now we have what we call the sign change here, right? I know one person will immediately say, no, my lowest common denominator there is x minus 3 and 3 minus x. But you can change the 3 minus x to be x minus 3 by taking out a common factor of a negative, so that you then don't have a lot of lowest common denominators there or terms when it comes to the lowest common denominator. We call this the sign change rule, right? Although it's just because you're changing the sign, so that's why we're saying it's a sign change rule. Now, what this will become, it will be x over x minus 3, and then it will be negative 2 over x minus 3, right? And then immediately you know that the denominator here, my lowest common denominator here will then x minus 3. I don't need to change anything, so it just becomes x minus 3. And this becomes x minus 2, and then that's my answer, right? You don't need to then, please, you don't cross out the x's and then do your own things after that. Please don't do that. All right, so let's look at one more example as well, and then we'll have one last one just after this. So here, remember, you need to look at whether the denominator can be factorized. If it can be, do that. If not, leave it as is. So you can already see there that 4 will never give me factors such that I get a 2 as my middle term. There is no way that will be the case. So this just becomes x plus 2 all over 4x squared minus 2x plus 1. And then the second term, you can factorize it, 8x plus 1. Then this one here will be the same as 2x plus 1 in the brackets because it's a cube, right? And this 4x squared. And then since this is a plus, it becomes a minus here. And then remember, because it's 4 there and the last one will be 1, it also becomes another 4 here and x. And then lastly, it becomes plus 1, right? And then you can take out your LCM from there, or LCD, which will be the whole thing that I have here, right? So you then can take that. So let me quickly write it for you. LCD will then be 4x squared minus 2x plus 1 into 2x plus 1 into 4x squared minus 4x plus 1. But this is one of those rare cases where the denominator cannot be factorized, right? Now, let's look at when now we are dividing. When we are dividing, what we need to do, remember I said tip and times. So this will be x into x plus 1. Already I'm factorizing. This is x squared. Then it will be multiplied by. This will be x cubed over. Here I can factorize this as well. X plus 1 into x plus 1. Then you then work it out, right? You do the cross cancellation, they normally call it that. So the squared there will go with that x there, and then this x will go into that x and leave 2 x's. The x plus 1 and the x plus 1. Lastly, my answer will be x squared over x plus 1. And that's my final answer. The beauty of mathematics. Now, guys, what we've looked at so far, to simplify an algebraic expression, you need to expand, right? Whenever the terms are in what? In brackets. Also, try to collect your like terms, right? Collect your like terms and then factorize to find the simplest expression, right? And please remember the types of factorization that we spoke about: your common factor, your difference of two squares, your trinomial, and your grouping. This was our map, guys, which we looked at. We said it's algebraic expression. We expanded a monomial with a binomial, bi with a bi with a trinomial. We looked at some fractions, some factorizing, which was a common factor, difference of two squares, trinomial, and some cubes. And I hope that clarifies a lot of things that has to do with algebra. Guys, I've had so much fun with you guys. I hope you also had so much fun like I did. And after this, you are ready to take on algebra with both hands and run with it. From me to you, I shall see you next time. Remember, from the Maths Doctor, mathematics is food for the soul.